Hello, welcome to 5-Minute Maths. Today we'll be going over summations and partial sums. So this concept requires a good understanding of geometric and arithmetic sequences. So if you do not understand geometric and arithmetic sequences, I strongly advise you to check out our videos on geometric and arithmetic sequences, link in description. And remember, for more quality content, please subscribe and hit the bell. Now let's get into the video. So what are summations? So summations are simply how mathematicians express partial sums. And partial sums are just the sum of the first n terms within a sequence. It's pretty much the name, the partial sum of a sequence, right? So how do you write summations? So we first have our sigma notation, which is the squiggly line you see. It's just, the sigma is just this portion. So that is the first part of the summation. The second part is right here, is this part where you see I equals to 1. So this is just a lower index. It just represents the lowest term you start with. For example, if I equals to 2, then the first term in your summation will be the second term within the sequence, right? And for the top one right here, n is the same thing. It's just the highest term. So for example, if n equals to, let's just say 7, then the highest term within your summation will be the 7th term of the sequence. So now I think xi is pretty explanatory, just xi right here. Xi just represents the formula for the sequence. For example, your formula for a sequence could be 3 plus 4 times n minus 1. Just any formula for a sequence, either arithmetic or geometric. Now let's move on to partial sums. So the formula for finding a partial sum of arithmetic sequences is n times a1 plus an divided by 2. N is the number of terms you're finding the partial sum of. A1 is the first term, and an is the last term. If you don't get any of the material we went over so far, it's alright, just bear with me. We're going to go over everything and practice problems in the next couple of slides. So after this, we have partial sums for geometric sequences. So the formula for partial sums of geometric sequences is a1 times 1 minus r to the n divided by 1 minus r. a1 is the first term, r is the common ratio, and n is the number of terms you're finding the partial sum of. So now let's move on to practice problems to make sure you understand these concepts. Okay, so before I do each practice problem, feel free to pause the video and attempt it on your own. But right now I'm going to start the problem. Okay, so our first problem is, express this using a summation. The partial sum from the 4th term of a sequence to the 9th term of a sequence. And the sequence is 6 minus 4 times n minus 1. Okay, so right now, our first step can be just writing the sigma, right? So we write the sigma, and then we can look at what they give us from the question, right? It tells us that it's from the 4th term to the 9th term. So we can obviously see that the smallest term will be the 4th term, right? So we can say I equals 4 on the bottom of the sigma. Let's make that 4 better. Okay. And since it's to the 9th term, we know that the 9th term is the biggest term. So we can just put 9 on the top of the sigma. Then all we need to do right now is just basically they give us the formula 6 minus 4 times n minus 1. So we just directly plug that into our sigma. So we have 6 minus 4 times n minus 1. And this is the summation for this sequence. Now let's move on to the next problem. Let's do the second practice problem. So it states that we need to find the partial sum of the 4th to the 9th term of this arithmetic sequence. 6 minus 4 times n minus 1. So you probably realize that this is pretty much the same problem as before, except we want to find the partial sum. So first, let's write out the formula for finding partial sum of arithmetic sequences. So that is simply n times a1 plus an over 2. N is the number of terms within our partial sum. So we know there's the 4th term to the 9th term. So that means there's 6 terms within our partial sum. So we know n equals to 6. A1 is the first term within our partial sum. An is the last term. So A1 is pretty much the 4th term. An is the 9th term. So now, in order to find A1 and An, we need to calculate the 4th and the 9th term. So let's do that right now. So we can just simply plug 4 and 9 into this given equation right here. So just 6 minus 4 times. So we want to plug 4 into n. So 4 minus 1. 4 minus 1 is 3. 3 times 4 is 12. 6 minus 12 is negative 6. So that is the fourth term. So now let's find the ninth term. So we just plug 9 into n this time. So we just have 6 minus 4 times. So now it's 9. So it'll be 9 minus 1. 9 minus 1 is 8. 8 times 4 is 32. 6 minus 32 equals to negative 26. So now we know the value of a1 and an. So now let's go plug this into our equation. So same thing. Okay, so we know n equals 6. So we first have 6 times, we know a1 is negative 6. So negative 6 plus, and we know an is negative 26. So just plus negative 26. And all of that over 2. So let's first find this. I'm going to use calculator here, so take some time. So that's negative 32 times 6, that equals to negative 192, divided by 2 equals to negative 96. So that is our answer. Do the third practice problem. So our problem is, find the sum of the first 6 terms of this geometric sequence. 4 times 2 to the n minus 1 power. Okay, so our first step is just writing down our formula, right? So we have a1 times 1 minus r, let's make that better, r, to the nth power over 1 minus r. So this is our equation, right? So we can see we have 3 variables, a1, r, and n. So r is a common difference, right? It's a common ratio. So we can see right here that's 2, right? So we know r equals 2. Now we can try to find n, right? So n is basically the amount of terms that we have in this sequence. So it says first 6 terms. So automatically we know that there's 6 terms in this. So we just know n equals 6. Now all we need to do is just calculate a1 by plugging 1 into the formula, right? So let me clear everything. And let's calculate a1. Okay, so all we need to do is just plug 1 into the formula, right? So we just have 4 times 2 to the 1 minus 1th power. As you know, 1 minus 1 is 0, and any number to the 0th power is just 1, right? So we know this equals to 4 times 1, which is equivalent to 4. So now we know a1 equals 4. So now let's plug all our variables into our formula. Okay, so now let's write our formula right here. So we have 4 times 1 minus 2 to the 6th, because that's 2 is our common ratio, and 6 is our n, right? The number of terms in our sequence, over 1 minus 2. And this would equal to 252. Okay, so this is our answer for the sum of the first 6 terms of the geometric sequence 4 times 2 to the n minus 1 power. Alright guys, thanks for watching. If you guys enjoyed, please share, like, and subscribe. If you didn't find it helpful or think it needs improvement, feel free to roast us in the comments. And yeah, thanks for watching.